Greetings to you guys. Welcome to our Maths and Vision classes for grade 12. My name is Mr. Tauzeni. Today we want to quickly go through differentiation from first principles. Please remember to like the video and subscribe. If you need any video on any topic, don't hesitate, just drop me a comment in the comment section. I will post a video on whatever topic you may want. We want to quickly go through differentiation from first principles. This is one of the sections of mathematics paper 1 where it's very much easy to make sure that you pass, you get full marks on this section because the questions there are not complex at all. Now let's get on with it. Our formula for differentiation from first principles says the derivative of f of x is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. This is the formula for the first principles. So let's say we want to differentiate f of x is equal to x squared. We want to find the derivative of f of x is equal to x squared using the first principles formula. Now, in the formula, the first part of the formula in the numerator, this part here, f of x plus h, it means we substitute x with the x plus h such that our derivative will be done in the following way. The derivative is equal to the limit of x squared now becomes x plus h and then squared minus f of x. F of x is x squared divided by h as h approaches 0. Then from here we need to simplify x plus h squared. For some reason we do have learners who make this mistake. X plus h squared is equal to x squared plus h squared. They just put the exponent inside here and they produce this answer. This is mathematically wrong. You can't do that. So the square means the bracket is multiplying itself twice. X plus h, factor of x plus h. Then we have to expand this using the FOIL method. So carrying on from here, our expression will become the limit of x squared plus 2xh plus h squared minus x squared divided by h as h approaches 0. So this x squared plus 2xh plus h squared is coming from expanding these brackets using the FOIL method. Then carrying on from here, this is the limit of x squared minus x squared. The rule for algebra when you are simplifying algebraic expressions is that you add or subtract like terms. So x squared and x squared subtract each other, then we are left with the 2xh plus h squared over h as h approaches 0. Then to simplify and finalize your answer, we factor out h. H is a common factor in this expression. So this is equal to the limit of h factor of 2x plus h divided by h as h approaches 0. The h that we have factored out and the denominator, those two are divided. So we are now left with the 2x plus h. Then h approaches 0, substitute h with 0, and the answer from this calculation is equal to 2x. This is my derivative after using the first principles formula. So important for us is to make sure that when they are marking this in your examinations, the notation is important. The derivative is the limit of f of x plus h. So if we remove the word limit and h approaches 0, the meaning will completely change. So make sure you have got the limit of this expression as h approaches 0. The only time you don't write the limit and h approaches 0 is when h has become 0. That means you now have the limit, which is equal to 2x, and that limit is the derivative the expression. That's first principles formula. Let's just quickly go through another one to make sure that we are all okay. Let's say, as my second example, I want to differentiate f of x is equal to 2 minus x squared. I want to differentiate this one using the first principles. The reason why I've chosen this one now is because of the negative sign. Most of the time, those negatives, I always say to my learners, negatives are culprits in maths. If you don't handle them well, they will mess up things for you. Just like negative people, you need to be positive. So let's see how we can deal with that negative sign. The formula for first principles says the derivative is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. Then we carry on to do our substitution. So when we do substitution in this case, we're going to have 2 minus x squared. In place of x squared, this x here is now x plus h. That's f of x plus h. So we have x plus h and then squared minus f of x. Notice when I subtract f of x, I'm going to subtract two numbers. So in maths, if you subtract more than two numbers, it's advisable to put them in brackets because you need to subtract both of them. So this is divided by h as h approaches 0. Now from here, notice that this whole part here in my substitution, this is my f of x. Then this one here, this is my f of x plus h, and this is my f of x. Then I can simplify this expression. So expanding the brackets x plus h squared is going to give me x squared plus 2xh and plus h squared. This is what I get after squaring. But because there is a negative sign here, I need to subtract all of them. Therefore, I keep brackets here to indicate that this subtraction is going to subtract the whole expression that I get after squaring. Then minus 2, the negative and the negative, they make it positive x squared divided by h as h approaches 0. Then we simplify. So this is basic algebra actually. This is the limit of 2 minus x squared minus 2xh minus h squared minus 2 minus x squared divided by h as h approaches 0. Then we simplify like terms. 2 minus 2 will give us 0. Then minus x squared plus x squared and plus x squared will also give us 0. So that means we are now left with the limit of negative 2xh minus h squared divided by h as h approaches 0. Then we factorize. Factorize. As a tip when you get at this level, if you notice that it is not possible to factorize the h here, it's a sign that your answer is wrong. You have made an error in your calculations. You may need to go back and check. H has to be a common factor here for factorization to be possible. So this is the limit of h factor of negative 2x minus h divided by h when h approaches 0. Now, the h that we have factored out is divided and this h becomes 0. So the answer to this question is negative 2x. This is the derivative of f of x is equal to 2 minus x squared using the first principle. So basically, we just need to know how to do the algebraic manipulation here. That is the bigger part of this expression. In some cases, we may want to do our calculations in the following way. I want to just redo one more, as maybe the last one. So let's say we want to differentiate f of x is equal to x squared minus x using first principles. So in my previous example and in this one here, check my substitution here and then you simplify until you get your answer. Noticing that when you're done simplifying here, it must be possible to factor out h and then you can replace the remaining h with 0 to get your final answer. In some cases, you are also allowed to work out your answer in bits and pieces, step by step. So if you choose to do bits and pieces, then your calculations, you calculate f of x plus h only on its own. So in that expression that you are differentiating, f of x plus h, you replace x with x plus h. So x squared becomes x plus h, and the x will also become x plus h. That is your expression. So this is x plus h squared. Then you simplify it until it is in its simplest form. So this is x squared plus 2xh plus h squared minus x minus h. And we simplify further. I think we are done because there are no like terms here. This is my f of x plus h. Then secondly, you calculate the value of f of x plus h minus f of x. Now this means from your previous expression that we have just simplified, we are going to subtract from this one the terms which are in the original expression. So f of x plus h minus f of x is equal to x squared minus 2xh plus h squared minus x minus h, and then this is our f of x plus h minus f of x, which is x squared minus x. And then we continue to simplify this. This is equal to x squared minus 2xh plus h squared minus x minus h minus x squared plus x. Now, we notice that like terms, this x squared and this x squared, they give us 0. Then minus x plus x, they also give us 0. So in simplified form, we remain with minus 2xh plus h squared minus h. That is the value of f of x plus h minus f of x. Then when you are done with this calculation, your third calculation is to now determine, you substitute. Your next calculation is to substitute into the formula. So you now substitute into the formula, remembering that the formula for first principles says the derivative of f of x is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. Now, if you look at this formula very closely, you are going to notice that the numerator, the entire numerator, which is f of x plus h, this whole numerator, that is exactly what we have calculated in our previous calculation. So it means when you do substitution, you are just going to remove this whole numerator and replace it with our answer in step 2. And then from there, we are able to carry on and simplify the expression. So carrying on from there, the numerator is what we have calculated. So our derivative will equal to minus 2xh plus h squared minus h divided by h. This is the limit of, I must not forget that one, as h approaches 0. This is equal to the limit of, now h is a common factor, so I have to factor out h, factor of negative 2x plus h minus 1 divided by h as h approaches 0. Then the h that we have factored out, you divide that one, and the remaining h becomes 0, so the answer is minus 2x minus 1. This is the derivative using the first principles formula. So you can actually do the calculations in steps like this, or you can do the entire substitution into the formula straight away and then work out your answer. Either way, you must be able to get the same answer. That's differentiation using first principles. So I guess sometimes you get learners who ask you questions like, oh, say, is it going to be like this all the time in maths? We don't want you to learn maths like the traditional rule. Maths is meant to develop your thinking. So sometimes you can learn a particular method and then discover that there are 2 or 3 more methods that you can apply. You are allowed to use any mathematically correct method in simplifying anything that you may want to simplify. So to just finalize this, I want to show you how to differentiate a fraction using first principles. That's one of the challenges that we sometimes face. How to differentiate f of x is equal to 1 over x using the first principles. So the method is the same. The derivative of f of x is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. That is my formula. So I am going to do the substitution, and then after the substitution I can simplify. Now in this expression 1 over x, the f of x plus h is 1 over x plus h minus f of x, which is 1 over x divided by h as h approaches 0. That is my substitution. So take note in this expression that this first part, the 1 over x plus h, that is my f of x plus h, and then the next one, which is 1 over x, this one is 1 over x, that is my f of x in that expression. Now I can simplify. Now if you look at this expression, you'll see that we have a fraction and then we have a denominator of a fraction. So it's some kind of a fraction over a fraction. So if you meet up with that situation, I advise that you change this division sign, a division line, into a division sign. If you change the division line into a division sign, you're going to have the limit of 1 over x plus h minus 1 over x. Then this division line becomes a division sign divided by h over 1. That is the expression. So here we need to work out these two and get an answer. If you remember, h approaches 0 here. If you remember from grade 5 fractions or somewhere there, to add fractions, we make the denominators the same. To subtract fractions, we make the denominators the same. So we need to make the denominators the same here so that we may be able to do this subtraction. So to do that, we simply are going to multiply these two. So this one here times x, and then this one we multiply by x plus h, and that one multiply by x plus h. That will make the denominators the same. So carrying on, we now have x minus 1 factor of x plus h divided by x factor of x plus h, and then divided by h over 1. Then h is approaching 0. So this is equal to the limit as h approaches 0 of, now here, if you simplify this, it's going to be x minus h divided by x squared plus xh. Now we need to remember something about fractions. When dividing fractions, the division changes into multiplication, and then h over 1, we swap h over 1 into 1 over h, then we multiply. So to carry on from here, this is equal to the limit of x minus x0, so we have got a negative h on top, divided by x squared plus xh, multiplied by 1 over h as h approaches to 0. That is our expression going forward. Then the h which is at the bottom here and that one, they divide each other. And after dividing them, we remain with the limit of -1 divided by x squared plus xh as h approaches 0. Then substituting h with 0 will give us our limit. Our limit is -1 over x squared. That is the derivative of f of x is equal to 1 over x using first principles. So basically, we need to know, just a recap, the formula for differentiation using first principles says that the derivative of x is equal to the limit of f of x plus h minus f of x divided by h as h approaches 0. And you must be careful when you simplify here, especially if there is a square or if they are negative numbers, because those negative numbers, if they are not handled well, they can mess up our work. Alright guys, thank you very much. That is about it for today. Differentiation using differential, using first principles. So like as I've already said, if you need anything, please drop a comment and then we'll make a video on whatever topic you may want to learn and tell me how it goes. Thank you very much. Have a good day.